His primary focus is the practice of lameness in sport horses, and his diagnostic capabilities include kinematic gait analysis. Now, as Dr. Hickman's presentation proceeds, if you have questions of any of these people at the dais, please raise your cards. Please be patient. The lighting is facilitated to maximize your ability to see up here, but it's kind of tough to see you from here. So please be patient. If you hold your card, we'll get someone to come and pick it up. Dr. Hickman.
Good morning and thank you. It's quite a privilege to be here among some colleagues that I somewhat idolize. So I find myself somewhat in awe that I happen to have the opportunity to be here. So, okay, my mom used to say I was that way from birth as far as digging for answers, but I will share with you some observations that I've made, track interactions that I think may have some merit and need to be looked at further, but keep in mind that they are observations. We haven't done any statistical analysis, nor have we enough data that we can support or refute any of these observations that you're going to watch. So they are observations at best. So is there hope? I say that simply because we've got a lot of holes being punched in our boat of racing, and we need to figure out whether or not we've got enough ways to plug those holes, and I think that's why we're all here. So the 2006 Welfare Summit brought about some great committees, some great learning experience. As I sat and watched the DVD, I was really amazed at some of the data that is out there that I was unaware of. Dr. Stover is sitting here, and I'm like, my goodness, how do I get on the platform with this lady? The risk of injury that she's developed here, as far as the statistical significance of those, the impact of a horse that's being injured, the musculoskeletal injuries especially. Dr. Arthur looked at some of the economic impact of that, up to $113 million per month in horse flesh that's turned over in order to maintain the numbers at a racetrack. That should be scary. So how do we make them last? Well, let's talk about some of the risks that are certainly involved. We can look back at a study that Dr. Gillette here in the audience was a part of at the detrimental effects. And let's look at some of that data from the respect of the economic impact as well as the musculoskeletal damage. Within their model, they hypothesized this footfall. And so if we look at that footfall, and I'll try to use this side, they've got this foot entering somewhat toe first and the cushion displacement that's there. So if that be true, we should have some type of cushion displacement on the front end of that. Now, I'm not saying it is or it isn't, but certainly I'm not sure that it's there all the time. So as we watch this film and we take into account that the leg has already started its backward arc, and we should have cushion displacement. We're getting some cushion displacement, but the leg is moving in line with its body. So we're getting that cushion displacement, but to a degree that we're going to create injury. And I guess that's, to me, the interesting concept here. And if we're looking at that, Dr. Clayton had some work that dates clear back to 1975, where they found some increased heat in fetlocks due to medial to lateral strain. So the thing that's not there within that model would be the medial to lateral movement that's shown in the green arrow and the rotational forces that are also shown there. But so graphically, there are some forces that are not accounted for within that. If we take into account that we put a cock on the front or a toe grab and add that into it, and then what does that do? And then we have to ask ourselves, are we looking in the right place whenever we begin to look at it from that standpoint? So if we look at some of the stuff that came from the Japan Racing Association as far as the biomechanics of the injury, when they loaded the cannon bone in a vertical direction or in a compressive force up to 10 tons, they had no damage to the bone, or at least there was none that they detected. Whenever they switched and loaded it in a transverse direction, they were able to break the bone at a much lower load, which you would expect. Now, if you take that and put the joint into it, the carpal joint. We saw some data as far as the carpal joints were concerned. And once you load that, as long as that force is in a vertical direction and it's compressive alone, it's fine. But they shifted it as little as 5 degrees, so medial to lateral strain, if you will. And what they found was, though on the outside there was no damage, on the inside we had fracture occur. So I guess what that would say is, what happens if we add medial to lateral strain and or those kinds of forces to the footfall, and where do they occur if they do occur? So what's the fault? Well, we've already established that it's a multifactorial problem. We've got lots of things that are going on. We've got things like conformation, the long toe, low heel syndrome, the racing surface issue. The training practices in this state or in these states differ somewhat from Europe. We've got rider influences that we are just beginning to understand. We've got other issues that we haven't even identified as yet. So where is the problem? Is it the race, or is it the training, or is it all the above? I put these in here simply because as I was putting together data, I got started looking at this, and we looked at the front end of the race at first. So as you look at that, we're looking at the difference between a level grip shoe, the second jump out of the box, versus a medium grip with a no vibe pad. And we don't find, at least in our expectation, we didn't find as much of a difference there as what we thought we might. The other thing that's interesting is that this is a quarter horse starting here, but the quarter horse starts more on his toes, so we don't get the dorsiflexion of that fetlock because the horse is up on his toe rather than having the leg fully extended. So there's some differences out of the box than what there is in the middle of the track, which should be intuitive, but there is also some difference in the braking process. So let's go on and we'll look at the next horse here. This is with the toe grab, and as we look at that, whenever we're starting, we're still not getting as much dorsiflexion as what they've established happens whenever you add a toe grab into this. Again, keep in mind, these are observations, these are just things that we have come up with. Here's a keg shoe on a horse that actually has the most fetlock drop of all of those starts. So I turned around and we shod that horse with a level grip and put him in here as a simulcam so that you could see the difference that he has in both a level grip and a keg shoe. So there was some differences for us. So let's turn our focus then to braking and deceleration of the racehorse, because I think there was some interesting things for us, and that can be resolved, the footfall can be resolved into the ground reaction forces, 3 vector forces. Those then are longitudinal transverse, but the vector force is the one that we're most interested in here. Initially, according to some of the previous studies, basically from Dr. Hillard Clayton's book, The Dynamic Horse, again, as far as the initial damage to bone, the sustained part of that being a soft tissue damage. So if you take into account the rest of the braking force, we've got a slow return to zero over here. So we're leaving the leg on the ground longer. The other thing that's interesting about that is the dynamic force that is placed on this animal whenever we have the center of mass change when the head is pulled up and out of position, or at least from the running position to a braking or deceleration fashion. How about the interplay of the center of gravity, how that changes, and the base of support whenever we move the jockey's position on the horse. So again, racing data from the Japan Racing Association, if I can get it to play, we'll do good here. So they had a video that was out that showed the interplay of the jockey to the racing injuries, at least that are on this film. So as we look at that, we'll look at the next one where the jockey actually plays a portion in this whenever he moves his position. So the jockey's position changes right there. The step caused the misstep, at least in their observations and their analysis of the video. So it's not a new thing. It's something that we've had around in the industry, but how does it all play together? And again, I don't think that we have all those things, but at least it gives me some indication that maybe there's some other things that we ought to be thinking about as we look at the pelvic fractures that occur, the pelvic injuries that are there. Are they occurring here at the start of the race, or are they occurring somewhere else? And if they are, how are they occurring, and how does that play into footfall as we look at the racehorse? So this is the one that got us started. I was analyzing this for my boss, basically, so that we could get an idea of what happened. This horse started this race. The jockey pulled the horse up. Whenever we got to the horse, we couldn't find anything that was overtly wrong, nor did we find anything the next day that was overtly wrong with this horse. However, as we began to slow it down and analyze it, now realize this is the track camera, so the resolution is not great, but as you can see, there's certainly some things that are happening here with footfalls and missteps and leg interactions, and this is all in a deceleration or attempt to brake here, if you will. And we've got jockey position that's changed, we've got leg fall that's changed, and how do those interplay? So that brought us to a point where we began to look at the finish line and the deceleration of the racehorse. And so these were just some camera placements. I put this slide in here just simply to give you an indication that it's not one horse across the field. As you watch these horses, whenever they stand up and begin to decelerate, almost every one of them switches leads. There's some changes in footfall. If you watch the number 4 horse here, we start getting some pretty drastic medial lateral footfalls that are going with this horse. If we go back to our Japan friends, how much is that interplay of 5 degrees movement and carpal injury and the fatigue factor that Dr. Stover's established, how much of that is going on? Well, this past fall. It was a race that I was watching. You can see right here where the jockeys changed positions just a little bit. The horse goes from a right lead to a left lead right there. And so there's some things that I noticed about this. He's in a left lead now. As he goes around the corner, the jockey begins to kind of take him in hand, slow him down into this clubhouse turn, begins to pull his nose toward the rail. That's nothing new. I don't think that it's isolated to our area, at least from what we can define here. However, the interesting thing is, begin to watch the left hind as it falls to the track surface here, the amount of movement that's happening up over that pelvic area. What's happening with the fetlock on the left front as that horse begins to decelerate going around the turn. And it left some things in my mind, at least, that I wanted to go look at. So based off of that, we took our cameras and we went to Anthony, which is another track, and I got that slide out of order, so we'll go ahead and play it since I was here. And my thought process was, what happens on a day-to-day basis? I happened to be there one morning while they were training, and I shot these. So if it is multifactorial, and if it is an interplay over time, what kind of strain, medial lateral rotational strain, is being placed on these babies on a day-to-day basis? Is this just our track? I can't say that I know that one way or the other, but it sure leaves some questions in my mind as far as what this interplay is on a day-to-day basis and footfall, and how does all this play into a catastrophic breakdown. Well, Bryce usually takes me for a ride in the country, tells me to chill out a bit, and so we ended up in Anthony. We ended up looking at some of these horses in a deceleration process. So if we can get it to play here, I left it in here kind of sped up. on a decreased resolution so I could get it within this PowerPoint presentation. He's moving kind of at speed. He's not being jerked up. He's just being slowed down. So as he begins to slow down, I hope you begin to appreciate that we are, in fact, getting some of this big cushion displacement now, even though the horse is barefoot. So if our toe grab plays a point, then I think that it's going to be here as far as the most interaction and the most damage as far as strain on that leg. I hope you can recognize then the rotational forces as well as the vector forces that are there. Can you see probably not, the big pocket of fluid that pops out on the front of the carpus there as he decelerates. As the right foot makes the entrance into the track surface, I hope that it's clear that the foot lands on the lateral branch first and we get a rotational force that's placed on that limb, and that in itself produces a pocket of fluid over the front of the carpus. Now that was a holy cow for me, and I got to admit that it was. So we put a horse in here that had a toe grab, and it's just a medium grip, but being pulled up a little bit harder. You can see her mouth open there just a little bit, and I kind of run it at speed so you can get an idea of the movement, but can you tell the pockets of fluid that are coming out over the top of this? As we interplay with the racing surface, now we can sure see how if we have a grab that takes a hold of the surface, that we can sure get undue strain up that limb. Well, we were in this turn situation, and we had this in our mind as we went to this, and so I asked him to stop this horse and make a left-hand turn with it just so that we could get an idea of what was happening. As the horse begins to decelerate and make this turn, so he shifts his body so that he can make the turn to the left. Take a look at what's happening with the left hind as it makes an interplay and the amount of movement that the hock, stifle, and pelvis endure in order to make that left-hand turn. So if we're decelerating the horse through the clubhouse turn, what kind of interplay are we placing over this pelvic limb to make that happen? So again, recognize that these are all just observations. I may have it backwards. I'm not saying I've got it right, but I sure ended up with more questions than I had answers for. Things like, can we expect conformation to make drastic differences here? How much is the conformation play an effect in how many horses break down or at least end up put back on the shelf? There was a lot of challenges to this project. I lost almost 300 gigabytes worth of data off of a hard drive, things like that, and things didn't always go as I had them planned. But I kept telling myself, you know, as long as you see two dolphins, you're okay. Well, that leads me to the final part. We've applied for some monies, and we're in hopes that we end up with a collaborative team between Pittsburgh State, Auburn, and myself in order to place some accelerometers on there. Why Pittsburgh State? Because they have a telemetry system out there. They have a telemetry system that's got a 3/4 mile radius that's able to pick up almost 1 million bits of data per second with over 120 sensors. So we can place multiple sensors on the animal. We're calling it a digital TINS patch. You can see that the antenna, the battery, and the accelerometer all is contained within a small gauze pad. If we can do that, then we don't have the interplay of a wired system, and maybe we can get some real-life data to correlate with a visual record to see if maybe what we're seeing is really happening or are we off base. We hope to do some further studies as far as comparisons, correlate it with the accelerometer data. Thank you.
Thank you very much. Are there any questions for this panel? Anyone hand in any cards? Okay. All right. Well, thank you very much. I think this has been a very good group. Some some levity as well as a great deal of expertise, and thank you very much.